This is a superconductor. It can be made of gold, copper, mercury, or any of these elements. But these aren't the normal conductors we see every day, like power lines or wires in everyday electronics. Normal conductors can be found in things like the wires in your gaming console to the cables in your car. These are what allows the batteries we use to power our toys and electronics. But superconductors are elements that can conduct electricity with no electrical resistance, when either cooled to almost 0 Kelvin or have a pressure of around 267 gigapascals. Now, why is it called a superconductor and how does it work? On April 8th in 1911, superconductors were first discovered by Heike Ones, who was studying the resistance of solid mercury. At 4.2 Kelvin, he saw that mercury had no electrical resistance. But wait, what is resistance? Well, it's pretty simple. Let's take a cycler, for example. It takes her 9 seconds to get from here to here in a straight line. She will represent superconductors. Now, if we add obstacles she needs to go across, she takes 11 seconds. This biker will represent normal conductors. In wires made up of normal conductors, it looks a bit like this. In superconductors, it looks a bit like this. See the difference? In normal conductors, the electron will hit the atom of the element they are in. When this happens, the atom will bounce around a little bit more, and then it'll hit more atoms, which will make it bounce even more. But in superconductors, it's completely different. Two electrons will link together and form a Cooper pair, which will then help them glide across next to the atoms without hitting any of them. This is the reason why superconductors lose no energy and can run forever. When the biker went in a straight line, they didn't have any obstacles they had to go through. They can just go fast and in a straight line. But when they had obstacles they had to go through, they had to swerve through them and slow down at the same time, causing them to take more time. This is the reason superconductors can run electricity forever. It's because they don't have to worry about anything. And in the future, we'll have superconductors in our phones, TVs, tablets, laptops, and many other electronics. The future is something no one knows, and while we think we know what's going to happen in the future, there's really no way to tell. Science is changing. It has been for the last few centuries. And who knows? Maybe the future holds something we